Welcome to the Archaeology Studio. Today's episode offers an introduction to geoarchaeology. By the end of this episode, you will be able to discuss what distinguishes geoarchaeology as a discipline or subdiscipline. You should be able to clarify the scope of geoarchaeology in relation to geology and archaeology, and you should be familiar with the kinds of questions that geoarchaeology can address. This presentation provides an introductory framework about geoarchaeology, and separate episodes can explore more specific aspects. In its standard definition, geoarchaeology refers to the use of geological principles and knowledge in order to solve problems in archaeology. The intellectual scope is within archaeology, while the theoretical approach, methodology, and technical procedures may be borrowed from geology. The most famous example of geoarchaeology has been the application of the geological law of superposition in archaeological research. Geological layers form in positions over one another so that the newer geological layers are in positions over the older layers. These layered positions can be described in their chronological order, referring to both their geological contents and their archaeological contents. An associated geological layer or stratigraphic context is essential for documenting individual artifacts, ancient cultural layers, and other components of the archaeological record. These contexts can define how and when archaeological materials were deposited in the past. Geoarchaeologists examine the formation processes of the archaeological record. Geological layers, sedimentary units, landforms, and complex landscapes constitute the material contexts in which we find specific archaeological materials today. Geoarchaeology shows us how those modern-day contexts of the sites that we investigate have transformed from their original ancient context of our archaeological interests. We can reconstruct or approximate those ancient contexts, but first we need to understand the time range involved and the geological processes that have occurred. When ancient site settings refer to contexts that no longer exist today, then they can be described as paleocontexts. You may see references to paleolandscapes, paleogeography, and other paleocomponents. In any case, the time range of the ancient context needs to be defined, and perhaps a series of paleocontexts can be reconstructed in their chronological order. From the micro scale of sedimentary particles to the macro scale of entire landscapes. Geoarchaeology investigates the relationships between archaeological materials and their contexts. In order to achieve these goals, first we need to understand how geological processes work in general and how they have affected archaeological materials specifically. Wherever you go in the world, you can see the diverse outcomes of the geological processes that have shaped coastlines, mountain ranges, river systems, cave formations, and other environments. Within each of those places, you can ask when and how archaeological layers were deposited, and then you can contextualize those specific ancient layers within their original settings. Each region naturally involves its own set of geological variables and time depth affecting the archaeological record. Geoarchaeology therefore needs to address different problems in each location. When referring to units of time, the archaeological record of human activity represents just one tiny fraction of the Earth's geological age of more than 4.5 billion years. Archaeologists work primarily within the current Holocene epoch and the immediately preceding Pleistocene epoch. Older epochs, such as the Pliocene, would extend back into the time of ancient pre-human evolutionary ancestors, such as the genus of Australopithecus, predating even the oldest known Homo habilis fossils. Geological time units refer to physical occurrences of certain rock formations, fossils, and other indicators of their time range. They can be ordered in a chronological sequence, and they can be distinguished at different scales. The International Commission on Stratigraphy provides a standard reference. The largest time unit is a super-eon, and currently only 2 have been identified. Most of the Earth's geological history has been within the pre-Cambrian super-eon that started with the formation of the planet billions of years ago. The current Cambrian super-eon started about 451 million years ago, and it represents the last 10% of the Earth's geological history. Within our current Cambrian super-eon, so far only a single eon is known as the Phanerozoic. Within the Phanerozoic eon, 3 eras are called the Paleozoic, the Mesozoic, and the Cenozoic. Within our current Cenozoic era, we can identify 3 geological periods of the Paleogene, Neogene, and Quaternary. Most of the geological formations that you can see today have taken shape during the Quaternary period. Even so, the Quaternary has accounted for about 1% of the Earth's geological time. The Quaternary period typically is viewed as most relevant for archaeology. So far, the Quaternary period has included 2 series or epochs of the Pleistocene and now the Holocene of our current time. We could divide or subdivide the Pleistocene and the Holocene epochs into finer portions known as stages or ages, depending on different criteria. Most importantly, though, we can recognize that the Pleistocene involved the Earth's last major glacial stages or ice ages, and now the Holocene refers to the current warmer conditions of a post-glacial or interglacial world. We do not yet know when our current Holocene epoch will terminate, but in theory, eventually it will transition into another glacial stage or ice age. Whenever the global climate has been notably cold, then large amounts of the world's water have been trapped inside ice sheets and glaciers. Eventually, warmer climate at a global scale will cause melting of ice and reintroduction of water into the world's oceans. At this global scale, we can look back at the world's sea level history as an accurate reflection of worldwide glacial stages versus interglacial stages. When we know about the different ages and cycles of global glaciations and change in sea level, then we can begin to appreciate how the Earth's surface has been shaped and reshaped. The amount of global ice at any given time has affected not only sea level, but also the shapes of coastlines, continental shelves, and land bridges, and other outcomes. The arrangements of ice-covered versus ice-free zones of the world have changed through time, directly affecting where people could live and the kinds of natural environments that they could inhabit. When studying concepts of more than 10,000 years ago, during the last glacial stage, we need to be aware of the shape of the inhabitable Earth at that time. Next, we need to consider how those inhabited land surfaces have changed since then until now. In some cases, ancient sites have become submerged beneath the ocean. In other cases, the moving and melting masses of ice have affected the underlying landforms and sedimentary units, as well as the settings and the habitat resources that could have been available for people. In a long-term view and at a global scale, the last major effects of changing ice sheets and sea level had occurred with the transition from the Pleistocene to the Holocene. The total change in sea level was more than 100 meters. Since then, during the Holocene, sea level has fluctuated on the order of just a few meters, but the effects have been substantial in coastal regions. A minor change of a few meters in elevation of sea level could affect hundreds of meters horizontally across a low-lying coastal landform. The effects are seen in the amount of available land, the distribution of fresh water sources just above sea level, and the configuration of natural habitats on land and at sea. Ancient sea level has been recorded in tidal notches that are visible today as diagnostic parabolic shapes along many coastlines. The process of creating a tidal notch occurs over many decades. It can be seen in action at the modern-day sea level. By observing the physical processes of beach formation today, we can interpret the layers of ancient beach surfaces in archaeological excavations. Beaches are among the world's more dynamic environments of site formation, so the lessons from beach formation studies can be especially instructive about the context of ancient site layers. In addition to changing sea level affecting coastal regions, large portions of the Earth can shift in their positions at any place around the globe through tectonic uplift, subsidence, or lateral movement. These processes tend to occur slowly, on the order of just a few millimeters over the course of several decades or centuries. One of the more extreme examples of tectonic movement has been in the eastern coast of Taiwan, where the eastern mountain range has been uplifting nearly 1 centimeter per year. In this case, sites on the modern-day hilltops at 40 meters elevation actually have been very close to the ancient sea level 4,000 years ago, around 2000 BC. Even older sites are found farther inland and at higher elevations, although originally they had been beachfront settings at 3000 BC or earlier. Modern road cutting has passed through some of those ancient beach ridges, where now the archaeological layers of 3000 BC have been exposed in profile view. In fact, several ancient beach ridges now are detectable as faint traces in the landscape, buried beneath more recent sedimentary layers. The farther inland you travel here, you can find older and older beach surfaces buried beneath the ground, eventually reaching a pre-human time outside the scope of archaeology. Geological formations and processes naturally extend much older than anything represented in the archaeological record of human activities. The island of Kauai, for instance, formed volcanically more than 5 million years ago. Dramatically deep stream-cut valleys and other landscapes have formed since then. Most of these landscapes were approaching their current conditions by the time of first cultural presence in Kauai and across the Hawaiian archipelago about 1,000 years ago. The Hawaiian landscapes certainly have changed through the last 1,000 years, representing one portion of what happened over the course of millions of years. At this point in the presentation, you can appreciate that one of the primary goals of geoarchaeology is to situate an archaeological site in its geological context. A research program could pose general questions about what a landscape once looked like, how the landscape features may have influenced cultural actions, and where we should look today in order to find the remnants of ancient cultural layers. Before we can address those questions, though, we need to understand how landscapes have evolved, how soils and sediments have formed originally, and how they have transformed through time. You can begin with the smallest unit of observation, looking at individual sediment particles, and then you can study how those particles have come to exist in their current layers and formations. The smallest particles are pieces of clay, and the next largest are known as silt and then sand. Larger pieces of rock appear in categories of gravel, cobbles, and boulders. Sedimentary units primarily are described by their compositions of sand, silt, and clay, with variable amounts of rock in the matrix. A sediment composition could be described as pure sand, silt, or clay, but typically some combination of different particle sizes will be evident. Several other aspects of a sediment could be recorded, for example in terms of the angularity of the individual pieces or clasts, the color when wet or when dry, the consistence, the structure, or the nature of the upper and lower boundaries. I will not review all of those details right now, but you should be aware of the range of possible observations. Whatever observations are being made, they need to be recorded in a standard conventional format for cross-comparability and potential integration of diverse findings. I will illustrate through one example of an excavation at Ukohola National Historic Site in Hawaii. The stonework ruins here relate to the royal residence and religious precinct of Kamehameha, his family and retinue, and their descendants from the 1790s through 1820s. The stonework foundations have been based inside the most recent sedimentary layers. Digging through those layers, I uncovered the buried remnants of older stonework features associated with different sedimentary layers of beach sand and terrigenous silts. By describing all of the sedimentary layers in a standard conventional format, I was able to identify the same components in different locations across the complex site area. I then organized the findings in chronological order, cross-checked with radiocarbon dating, and recorded the precise depths of each layer in every mapped test pit location. In total, this information portrayed how the whole site area had transformed through time, in terms of the shape of the coastline, the distribution of sedimentary layers, and the cultural use of the changing setting. These results revealed a complex, changing landscape at the site, telling a story of more than meets the eye at first when admiring the historical stonework ruins. One of the strengths of geoarchaeology involves the ability to clarify ancient site contexts within the observable physical world. We can examine those ancient contexts in many different ways, investigating how the archaeological record today relates with the formation of soils and sediments, with landscape histories, with records of ancient shorelines, or with other factors of the geological environment. As I have presented here, geoarchaeology is essential in archaeological practice, at least at some level, whenever we obtain factual material data from ancient contexts. In this view, we may need to reconsider how we think of geoarchaeology as a subdiscipline of archaeology, as a separate discipline or hybrid of its own, or as a fundamental part of the definition of archaeology. Much of this philosophical debate depends on how you view geoarchaeology as capable or not of generating its own research questions and implementing its own methodologies and techniques. Similarly, you might ask what kinds of studies even are possible in archaeology without any input from geoarchaeology. In concluding this episode, now you should be familiar with geoarchaeology in its scope, purpose, and relationship with archaeology in general. You can identify the issues and questions that could be addressed through geoarchaeology, and you can evaluate the potential for geoarchaeological research in any particular case. I hope that you enjoyed this episode and that you will explore more with the Archaeology Studio.